Hey, what's up guys? Welcome to another WebAssign problem. This time is rotational dynamics, and it says the top in the figure has a moment of inertia of 5.50 times 10 to the negative 4 kilogram square meter and is initially at rest. It is free to rotate about the stationary axis A prime, then a string wrapped around a peg along the axis on the top is pulled in such a manner as to maintain a constant tension of 4.32 newtons. If the string does not slip while it is unwound from the peg, what's the angular speed of the top after 50 centimeters of string has been pulled out of the peg? Now, the statement, not the question, the statement is pretty big. Yes, I know it's huge, but the question is small. What's the angular speed of the top after 50 centimeters of string has been pulled off the peg? Easy. Now, so what the problem here says is, hey, you've got your top. If you pull the string, it's gonna spin, it's gonna rotate, right? Now, if you pull it 50 centimeters away with a tension of the string, which would be our force of 4.32 newtons, how fast, what's the speed, as it says here, what's the angular speed of the top after you pulled it 50 centimeters? Now, we must note that we've got a moment of inertia here, 5.50 times 10, blah, blah, blah. We've got tension, which would be force, and we've got distance here, it's 50 centimeters. Now, if we get that the work will be the force times the distance, now it is W, remember? This case, as we're talking about tension, I'm gonna put T. It will be the same because it's in newtons, the units. So now the distance, I'm gonna call it S. So the work will be the tension times S. So now this guy, rotational kinetic energy, my fella, says, hey, also W would be equal to the half of the moment of inertia times what else? Times the speed, the angular speed, but squared. Now, if we do this thing, then we're gonna then put TS, gonna leave it in here, I'm gonna put TS on this side. So now we'll get that TS is equal to the 1/2 of I times square W. What does this mean exactly? This is something like this. So we're gonna get now our equation is TS would be equal to the 1/2 of I times W squared. Now, I'm gonna make a quick pause in here. But before that, we're gonna see that the problem is asking me what's the angular speed, right? So then, in this equation, I have here the angular speed. Of course, I have to clear my variables and stuff. But now, we're gonna look at the drawing, which I strongly recommend doing this analysis first. And it is naming what is what. So now, this will help us to swap values in here. So the thing is that I'm gonna get that the tension, which is our force right here, it's gonna be 4.32 newtons, 4.32 N. Now the distance is 50 centimeters, but we're gonna work with meters, right? We want the most common units. So then this is all of this is 50 centimeters, which I will call 0.5 meters, and this is S. So now, what else am I missing? Well, I'm missing the moment of inertia of the top. I will just name it here, which would be I, and it'll be 5.5 times 10 to the -4 kilogram square meter. Now, we've got everything in here. We've got tension, which is this. We've got distance here. We've got moment of inertia here. Now, we need to clear this guy. So, for that, I'm gonna grab this 2 that is dividing this whole couple of guys. It's gonna go to the other way. It's gonna multiply, so it will be something like this. 2 times TS. Now, we've got rid of this guy. Now, this guy is multiplying W. So, it's just gonna go to the other way, dividing. So, we've got this is this. And you know, as to get rid of the squared, we're gonna put this little guy. So now, what I just need to do is to swap my values and get the exact value, or almost the exact value of the angular speed. So for that, I'm just gonna write the square root of 2 times the tension, which is 4.32. I'm gonna skip units because the common angular speed unit will be rad per second. So don't worry about it. So now this times distance, which is 0.5, and we divide this by the moment of inertia, which is 5.5 times 10 to the -4. Now the time has come to utilize my calculator. And so I put square root of 2 times 4.32 times 0.5, and I divide this by 5.5 to the 10 times 10 to the power of -4. Now I get an angular speed of, we'll write it right here, 88.62 rounded rad per second. Now, this has been another WebAssign problem, rotational dynamics WebAssign problem with Bob, el profesor.